Thank you so much for having me. So thanks for bearing with me. Last talk of the day. It's always hard. I know everyone is a little bit sleepy, but there's exciting stuff in here. First question might be, wait, what are we doing here? Like this PyCon, PyData. Like shouldn't this be really Python? And like this is what I want to start with. Like everybody knows Spark, but Spark is this weird Scala beast. Like JVMs and stuff. Like wait, what does this have to do with Python? So my number one question, and I really take this from a previous speaker because I like the interactivity. So how many people here have used Spark before? Oh, wow. Ooh, nice. Ooh, I'm a database person. I come from C++ background. Like all of this Scala stuff is still new to me a little bit. So how many people are using PySpark in kind of a regular basis? Oh man, that's awesome. So how many people love debugging PySpark stuff? I mean, one person loves it. Wow, I mean, that's much more than anticipated, And, the reason is the evolution of Spark. Spark, back in the days, built in a way that we typically today associate with large data centers, large clusters. So we've built all of these applications, and everybody that has ever deployed like this ML app, this kind of IoT app on Spark, essentially really boils down to like deploying it together with Spark. There's no concept really of deploying an app next to Spark. It's like always one thing. And the reason is, oops, there's a slide missing. The reason is that everything in Spark essentially is really tied down into the Spark driver. This is like this whole JVM interop between like Python and JVM. Like this is really hard. But data applications, as we've seen like many different places, they don't live in data centers anymore, just in data centers anymore. So like everybody wants to use like PyCharm for development, VS Code, Jupyter Notebooks. We want to write web applications not just in Python because we love it, but there's like weirdly this other languages like Go and JavaScript, that people want to use. And then on the other hand, like we have these edge devices. Like everybody has a phone, like with lots of computing power. Like we have like all of this other stuff. And the question is like, why can't I use Spark from these devices? Like, why do I have to always think in Spark in terms of like, I have to deploy this using Kubernetes, I have to go to Amazon and pay lots of money, or Databricks, yay. But at the end of the day, it's like, why is this so complicated? And really, if you zoom in, as I said before, your application logic sits right on top of the whole Spark stack. So it's like right next to the analyzer or the optimizer before it gets scheduled and executed. But if I want to embed Spark in my application, like I get to this kind of big problem. I have to use SQL. I mean, SQL is awesome, don't get me wrong. But everybody that has tried to build like a dynamic app using SQL knows that it ends up being like string concatenation. Like everybody that ever said like, oh, let's just add a dynamic filter to my SQL string here. Yeah, right, you build like a CTE and then a with statement and another one, but wait, how do I debug this? This, and then, you talk to a data engineer, they said, oh, have you used DataFrames? And you say, yeah, no, because, well, DataFrames don't really work there. So the question is like SQL only, but if I want to use my IDE, my notebook, the things that I'm used to, I'm a software engineer, I don't like notebooks for developing code. Notebooks are awesome, for interactive stuff or like, like doing stuff like really ad hoc. But if I want to develop an ETL pipeline, I don't use a notebook. I mean, don't get me wrong. I mean, if I say this out loud, half of my company is going to yell at me because they believe notebooks are awesome. They are, but for their own kind of purpose. But if I want to use an IDE in a notebook, I have to basically deploy my code close to the REPL. The REPL is basically, we know it in Python. It says runs like right next to Spark, which means I have to run Spark locally, or I have to SSH to node that runs Spark, and this is complicated. If I want to use a programming language that does not have any kind of interop with the JVM, I can't use Spark at all. If I want to use Go, I'm kind of toast. There is Spark R, but everybody that has ever done anything really with software engineering and Spark R, I mean, it works, but whew, it's a whole different beast. All right, so this is the reason why over the last year, essentially, we built Spark Connect. The whole goal of Spark Connect is build this kind of thin client API that allows you to use the power of Spark from anywhere, like using it from your IDEs, from your applications, from all these kind of different programming languages. So how do we achieve this? When we looked at the way how the Spark API is essentially built, like the DataFrame API, the key APIs that basically have evolved over the last 10 years, there's really like we have this DataFrame API that gives us a declarative perspective of how to access the data. If I'm saying like Spark read table, then select and write and insert into, all of this is like declaratively identifying like what kind of operations I want to do on my workloads. We take this API, we translate it into a logical parse plan. Why parse plan? Because on the client side, we don't really know, like, is this a table? Is this a file? Is this Parquet? Is this CSV? Is this JSON? This information is handled best at the Spark server, so we want to push this there. We then take this unresolved logical plan, we send it over the wire using gRPC, and then we process it on Spark. You can use all the plugins that you're using in Spark. You can use all the power of Spark, the Spark ecosystem that you have today, continue using it, and use Spark Connect. And then the results are streamed back using gRPC and arrow data to the client. So we started the project with this Spark improvement proposal roughly in May 2022. And now with Spark 3.4, actually the first version that Spark 3.4 was released last Friday is available as open source, and you can use it, you can directly get started. So what is the status of Spark Connect in Spark 3.4 today? Essentially, if you're using Python for all of your data science and all your data management or data engineering processes, like, it just works out of the box. You can use DataFrame APIs, UDFs, dynamic conf, all of this is there. We even have like an experimental Scala client that allows you to use more or less the untyped data set APIs from Scala and use it as well and connecting remotely from IntelliJ, for example, to your Spark cluster without like SSHing to something. However, there's a trade-off. Like this sounds like, oh man, this is so awesome. Like, why haven't you done this like 15 years ago? And the answer is, Spark is 12 years old. So there's a lot of evolution that has happened in the different APIs of the system. And there are parts of Spark that still exist, are still powerful, but they're not really client-friendly. So RDDs, for example. Like, I don't know if people remember like the RDD paper from like 14 years ago already. I mean, I'm way too old, it seems. This was like the beginning of like why Spark is so successful. And RDD APIs was this kind of like this powerful improvement over MapReduce and really showed like what you can do with a new kind of in-memory processing. But the downside is they're very low level. The DataFrame API is like high-level declarative implementation, and RDDs are this kind of low-level, I really know what I'm doing, the assembly, so to say, of like data processing. But doing this on the client side, if you want to debug from your Python application, this is really not the way what you want to do. So here's really where it's saying, OK, please don't use RDDs, and we don't support RDDs in this API. And essentially, we are giving a simplification from this kind of 3 different APIs that you have today in Spark to only 2, focusing on the declarative APIs that can be optimized using the built-in optimizer, Catalyst, and so on. If you have your application and you want to migrate it to Spark Connect today, there's a couple of things to be aware of. Number one, that is, for some people a little bit surprising, is you don't have access to the driver JVM anymore. There are surprisingly many, like even Python applications that somehow use Java under the hood. And you might not even be aware of that, but this is something that, because now your client doesn't run anymore on the Spark cluster, you don't have access to the driver JVM anymore. In addition, the Spark context as this kind of like application singleton is not available in the same way. And we believe this doesn't fit really on the client because it's a server-side concept. So what's the UX then? Like, what does actually change? So to basically show you how to connect to Spark, a remote Spark cluster, we added this kind of remote property to the Spark session builder, which identifies a Spark cluster given a connection string. The connection string of a Spark Connect is very similar to any JDBC connection string. So basically saying like, hey, this is my host name that I want to connect to, that's a port number, and so on. Spark Connect as a protocol, as I mentioned, is gRPC-based, so it's standard HTTP2. So wherever you can deploy any kind of HTTP2 traffic today, you can use Spark Connect. It works really easy. In Databricks, we run it behind an Envoy proxy. I talked to tens customers in the last couple of weeks. There's like Envoy proxy. We talked about integrating this in Kyobi. And there are like many different open source projects that give you this kind of flexibility of deploying HTTP2 proxies. So in Spark 3.4, as I said, Spark Connect is available. It's publicly documented. It's all in docs. And what's even better is in Spark, essentially, now they have these kind of live notebooks that are supported by MyBinder. So it's basically running a Docker container with Spark inside, where you then can run interactively, try this out in your browser, and run this quick start notebook for Spark Connect to really get like an idea of like how to use the system. All right. But the thing is, all of this is open source, but I get paid by a different company. And so I want to talk to you a little bit about like where does Spark Connect come into play for Databricks, and like why do we believe this is so important and such a game changer for us as well. So as I mentioned before, Spark Connect gives you the ability to connect to your data lakehouse like from anywhere. And this is really what we care about. Like Databricks is the #1 provider for data lakehouse platforms, for giving you the ability to collect your data, process your data, do machine learning on top of it, integrate this into your MLOps flows and everything. So wherever your data is, whatever your problem or whatever you're trying to do with your data, we basically give you the opportunity to integrate with us. And then using Databricks Connect, which is built on top of Spark Connect, you can then integrate from all different areas. So this is not just IDEs and notebooks, but this is as well data applications. So you've seen outside there's a booth from Plotly. You know, like we've shown like how to integrate with Plotly, Streamlit, all of these kind of like new kind of data application tools that give you this interactive experience. And then of course we have partner integrations using Data IQ that are all using the same API to build new kinds of applications for the data lake. So why do we care so much about IDE-based development? Because developers like it. You know, like if you're using Databricks today, you're thrown into a web interface, and then you have a notebook, and this is you get started. And you know, this is awesome. You know, like you built your first pipeline, you schedule this as a job. This is great. But at some point, I'm asking, so how do I write a unit test? How do I test this? And then somebody says, oh, I found a GitHub project that allows you to run PyTest in a notebook. And you say, awesome. That's really what I always wanted. Like this is what I dreamed of my whole life. I don't. You know, I still believe that unit tests are run locally. And the question is like, how do we basically give customers and users the ability to use all the muscle memory that they learned over time? You know, they all went to like school, university, like wherever they learned their best practices. We want to give them the ability to use this. You know, so we want to say, okay, whatever you learned and whatever fits your job, the way that you want to do your task the best, we want to give you the opportunity to continue using this. So this is why we believe like it's not just in the notebook, it's from everywhere. In Databricks, we had something called DB Connect v1. So to say, this was our first approach to this topic, and it works. It's kind of clunky. It does its job, but it's not really extensible. It's not really fast. And you know, like this project has been in maintenance for a couple of years, and now basically with Databricks, with Spark Connect, essentially we're pushing a completely new way forward in a much more lightweight way. So what it allows you, DB Connect, is like whenever you have a Databricks cluster somewhere running in your infrastructure, you can connect from anywhere, from the IDE of your choice, being it PyCharm, being it VS Code or whatsoever, and you get the benefits of not just having like debugging, but you know, like the larger your company gets, the more sophisticated your processes are around data. Like data governance becomes important for you as well. So it's no longer just, oh, can I write my unit test? But it's like, can I write my unit test in a way that still respects like all of the data governance rules that I have set up in my company. So and this is really what we want to do. And to get started, it's very simple. You know, since today, essentially we're going public preview today. Pip install Databricks Connect, depending version larger than 13. And now you can connect to your Databricks cluster from anywhere directly, from your laptop, from wherever you want, and it's very simple. To get started, all that you need is, as I said, you need the package. You take your workspace URL, your cluster ID, and off you go. I know this is kind of like, hey, this is not a Databricks show, but you know, just to like, if you look at the slides later on, it's very easy to get started. So again, you know, like our goal was like, how do we make this backwards compatible? Like for us, the most important part is there's so much code written today in PySpark, you know, that you want to continue using. We don't want to push on you, or we don't want to prescribe you a particular way how you have to continue of writing your code from now on. We want to make sure that the same open source way of using PySpark continues in the same way, and that you can simply use it, but you're using it now on Databricks. So you know, if you take this example, you can run this like on on like plain vanilla PySpark, it works. You can run this on Databricks, it works. You can move this to DB Connect, and it works. You know, and this is what we wanted to achieve. We want to make sure that whatever we're doing, it's compatible to the to the existing versions. So this is just like an animated GIF that I did some time ago, you know, like to show you, hey, how easy it is now to basically interact with remote cluster. So in this particular example, I just wrote a simple test where I'm like scanning a table on my remote cluster, and I set a breakpoint because my test was failing, and now I'm basically, you know, everything that I'm used to, basically being able to debug my code locally in Python, I can still do. So I can get all the benefits that PyCharm offers me in this case, to like inspect all the values, I can interact with the system, but my PySpark is not running locally. I don't have this PyCharm, I don't use what's called IntelliJ Fleet or something like this, where you now have like remote running instances of your IDE. No, this is my PyCharm running locally on my MacBook that connects using Spark Connect to remote cluster, and this can be whatever. It can be a single node cluster, it can be a 100 node cluster, it can have a terabyte table, it can have a 20 megabyte table, it doesn't matter. Like all of the things all of the data that is available to me, I can use. And this is really the power, because imagine you have your complex ETL pipelines and you're trying to debug why, for whatever reason, your zip code all of a sudden contains a letter while you didn't expect this, because in Germany all the zip codes are actually numbers, until you realize in England that's not the case. But you really, like, how do you do this? Yes, you can write a unit test, but sometimes you just want to look at the data. And this is really what, the difference, again, like it brings back this combination of like the ad hoc interactive analysis of the data and combines it, with the, the standard software engineering approaches. In addition to just local development, this enables a whole different area of completely new use cases. It becomes very easy to write completely new interactive data applications with very little code that you need. So for example, as I mentioned, like we have a public GitHub repository that shows how to use Dash and Plotly with our sample data sets in, I think, roughly, I would say net lines of code is probably 100 lines of code to give you this kind of interactive map visualization where every time you're changing something, it like actually goes back to the server and runs a full query. Yes, of course, you could do this today already, but just with SQL. But again, now you have PySpark available, you can really leverage all of the benefits of that. And then another one is we have a partnership with DataIQ, where DataIQ is a provider that builds low-code, no-code ETL pipelines. And they have a breakout where you can write PySpark code, essentially, to integrate with Databricks. And now they don't have to like run this as a notebook or a job in Databricks. They can interactively trigger this from their pipeline, making it very easy to combine SQL pushdown with PySpark pushdown and all of the other operations that they have in their systems. And as I said, you integrate from any application. Like you can take this example. This is the most minimal. It doesn't produce this awesome map there, but the most minimal example to run a Dash app is exactly these kind of like 10 lines of code that you can deploy in a Docker container, run it anywhere, and just use it. And then you have basically a new application deployed using Spark. You don't need to explain why I need a new kind of like data management system. You can continue using all of your existing data science tools that you have. Partner integration, as mentioned, DataIQ, really the ability of pushing down additional PySpark code directly to the Spark cluster and making it available so that, because again, the interesting part is coming back to the previous talk, you're not the only persona in the company. Well, like the data scientists basically writing code, like of course they know what they're doing, but there are many users out there that really look at this and say like, I understand half of it, if I'm lucky, but most of the time I can like roughly point and click, and that's why there's so much success in this kind of low-code, no-code tools, because they give you the ability of like onboarding users and onboarding like knowledge that you couldn't access before. However, most of the time, these kind of tools had a limitation that there's a limit to the complexity that you can express. With the integration that we're doing here with DataIQ, you really get the ability of saying like, I can onboard the users that have a good understanding of the business case and they can express it. But in addition, I can now offer them the ability to push down even more complex logic if they need to. Again, like this is my job as a Databricks personality. I have to basically give you an idea of a roadmap. So we went to the public preview today. Like, the US is waking up, so I'm expecting the blog post to be published in the next hour or so. So today we have support for Python and PySpark. MLflow support is there for single node ML. Authentication, standard token-based authentication, AWS and Azure. GCP is coming in the next couple of weeks. And as we are marching towards GA of the product, like our goal is to have full support of the pandas on Spark API as well. The ability, we will run Scala support in a private preview, and as well full Delta support. Like for us, it's not just on the client side, just reading the data, but as well writing the data, using the power of the open Delta Lake to be able to integrate. And as part of that comes as well, like making sure that we have the full enterprise integration, Auth and Azure AD and so on. And then in the longer term roadmap, R again comes up because there are customers, especially in the financial sector, that are using R, and it will not go away. I mean, we had the discussion earlier about like COBOL, like it's been trying to die for a long time. It's not happening. And I think, like R will have the kind of same faith, like it will remain there. And we have to make sure that we pick up the users from where they are. And with that, I conclude my presentation, and I'm happy to answer any kind of questions that you might have on this topic. Thank you so much.
Thank you so much, Martin. We have a bunch of questions on Slido, so I'm just going to jump into the first one. Does Spark Connect provide a mechanism to instantiate a remote Spark cluster?
No. So Spark Connect is really more the connection protocol. In Spark, so there are 2 open source projects that give you the ability to create the Spark clusters. Like one would be Kyobi, which is a relatively new one that is more like a SQL gateway on top of Spark. And then there is another one that I forgot which name it is. It was kind of dead, but was just recently reanimated. So it's not. So Spark Connect's job is not like instantiating the Spark cluster. There are other open source projects doing that. Spark Connect is really more the protocol.
Great. How does UDF execute it now?
So the UDFs, the Python UDFs, are executed in the same way. And so basically and this is, I don't even dare to say this, like we cloud pickle the UDF closure and we send it over the wire. This comes with all of the downsides that you've heard before. That's unfortunately the way that in PySpark the UDF execution works. We don't try to change this. If anybody here is interested in like doing something that is better than Cloud Pickle and more portable, like please let me know. Like I'm totally happy to figure out a way how we get this in PySpark. But I think like Cloud Pickle unfortunately is the today's solution.
Okay. Is the same Databricks Connect code I wrote locally be prod compatible if I were to deploy it to Databricks via CI/CD or Terraform, or do I need to adjust it?
No, essentially the goal is that the code that you're writing locally, even if you're using PySpark open source locally, that this code is prod compatible. Like we want to improve the fidelity of the inner dev loop of the engineers.
Very cool. Is it possible to see afterwards from which source the code ran? For example, for cost analysis to check whether unit tests that need clusters are increasing costs.
So you have the visibility into from where the calls came mostly by the users that ran on your clusters. So the same cost attribution that you're having on your existing Databricks clusters, all of this works in the same way. So there's no specific check for like logging for DB Connect access.
Okay. For unit testing Spark apps in CI/CD, is it possible to have a local Spark version or environment in standalone mode that is identical to the Databricks runtime?
Completely identical to the Databricks runtime is a little bit hard because, as Databricks, we have our own bells and whistles that we have like around our Spark runtime. However, like from a core functionality perspective, like a local PySpark gives you roughly the capabilities of the respective Databricks version. Of course, if you're installing your local libraries, you have to make sure that they're installed as well on the Databricks cluster.
Okay. So far in my experience, PySpark is much slower than native SQL in Databricks. Is it the nature we only use PySpark when SQL couldn't do more advanced analytics?
So in theory, that shouldn't be the case because PySpark and SQL boil down to the same execution engine. They boil down to the same execution plans and they run through the same analyzer and optimizer. I mean, like a good example to see this is if you're searching for Spark SQL, you're actually not finding SQL text, but you're finding like all the like SQL, Spark SQL means data frames essentially. So that's why it's very unlikely that SQL code, like string SQL, can be much faster than PySpark because it's the same. If you're like injecting RDD somewhere in the middle, like it becomes an opaque optimization blocker. If you're using UDFs, obviously they become slower. So sometimes, I've seen customers and users basically instead of calling, the PySpark SQL function like upper, basically creating a UDF that does string upper. Because it's convenient. Like they didn't remember then the function name in SQL, so they just wrote a small UDF that does this. I mean, obviously this is like tons slower than just using the native SQL functionality. But otherwise, it should be the same performance.
Okay. When would you recommend using one of the other methods to run Spark in IDE, namely VS Code plugin or Databricks extension DBX?
So the VS Code extension, like we're integrating right now with the VS Code extension, the VS Code extension will be updated as well to support the native debugging capabilities. The reason for using the existing, let's say, DBX way of synchronizing the code to notebook in Databricks is mostly if you're using not the most recent release of the Databricks runtime. So if you are for unfortunate reasons, stuck on an old release, then you have to use the old ways. If you can migrate to the Databricks 13 release, which was released last Friday, then you can use the new way of connecting to Databricks.
Okay. Are there plans to integrate Kerberos auth?
No, and the reason is, in Spark, generally, we try not to be prescriptive of the way that you deploy your cluster. I mean, if you look at Spark, you can deploy like using Kubernetes, using Yarn, using whatever you want, like local cluster mode. And like Kerberos essentially is one way of doing authentication, but like this is something that we believe should be handled outside of Spark Connect and outside of this particular implementation. This is something where like a proxy in front of Spark Connect is a much better place to do this kind of authentication than trying to hook this into the Spark Connect protocol itself.
Okay. How can the cluster dynamically check if it is started locally or from Databricks UI? Because depending on that session, construction differs, doesn't it?
I'm trying to unpack this. So the easiest way to check how the cluster was started, I think, is checking the master property in Spark in the Spark conf, which should tell you if you're running in local mode or if you have a master UL set. But I think I'm not 100% sure what the question tries to get at. So it would be great to rephrase it and like give me a little bit more hints on like where this goes to.
Okay. We still have time for questions, so whoever has that question can re-ask it again. Or maybe we have another question from the audience. Or we can go to coffee break 5 minutes early. What would you prefer? Okay. Thank you so much, Martin. That was a great talk.